Hello and welcome to a brief video that introduces the Math148 project. Let's start with some background. In this project, we're going to assume that we have a company that's bringing a brand new innovative product to the consumer market, and that our company is going to have a temporary monopoly with that product. That basically means that we won't have competition from any other companies, at least for a while. Our company has collected data and/or created mathematical models for cost of production, demand, and supply conditions. We'll talk about what that means more in the course, but for now, let's focus on the big picture. Here's what we call the class data set. This is similar to what you're going to receive, which will be very similar, but will be randomized and so different than what you see here. In the class data set, we'll use these pieces of information to show you how to apply the ideas from the course to your own project data. We'll each get 3 basic pieces of information. The first one is going to be a cost function, C of Q, which tells you the total cost C to produce a quantity Q of the item that your company is trying to sell. We'll also get a set of demand data for and from consumers in that market. The data will look like this in a table. For example, this first line tells us that at a price P of $556.08, we can expect to sell 200 items at that price. If we want to sell more items, such as 700, a quantity of 700, then the price would have to be lowered to incentivize consumers to purchase that item. The third thing that we're going to have is called a supply curve, or a supply function, S of Q, which measures the supply conditions for this product in this market. We will discuss this later, but for now, let's just focus again on some of the big ideas of what's going to happen in the project. Each person, or each team, will get these 3 pieces of information. And then we'll be exploring these functions in different ways, including graphically. For example, here is the supply and demand curve. This point where the orange demand curve and the purple supply curve meet is called the equilibrium point. And so we'll explore that a little bit later on in the quarter. We'll also be generating and graphing our cost curve, which is given to us, a revenue curve, which is not given to us, and a profit curve, which is also not given to us. The cost curve in red is a linear function that corresponds to the equation that we saw in one of the previous slides. But we will have to build the revenue curve, which is here in blue, and we will also have to build the profit curve, which is here in green. This graph tells us the relationship between the quantity that is sold or produced and the amount of dollars of revenue, cost, and profit. In the project, we're going to be looking at the important question, what is the maximum profit that we can make? That corresponds to the peak of this green profit curve. You can see here roughly that the maximum profit occurs at approximately maybe 625 items sold. In addition to trying to identify how many items are going to maximize our profit, we'll also ask and answer the question, how much should we charge for each item in order to make this maximum profit point? This analysis here will be among the most important ones that you do in your project. One way that we will do that is by looking at marginal functions. We will be able to create marginal revenue, marginal cost, and marginal profit functions using calculus and tools called derivatives. In your economics class, if you've taken one, you may have heard that profits are maximized when marginal revenue is equal to marginal cost. On this curve, that would mean when the blue and the red lines cross each other, here, our profits should be maximized. We will explore that in much more detail later, and we will generate these curves using derivatives from calculus. We'll also use another tool from calculus called integrals or integration to compute things like the consumer and producer surplus. The consumer surplus is the area trapped between this green dotted line, the orange demand curve, and the vertical axis. The producer surplus is the area here of this triangle labeled PS. Now, finding the area of a triangle is relatively simple. We have formulas in geometry that do that for us. However, finding the area of the consumer surplus region here that I'm outlining is a little bit more challenging because this side of the enclosed region is not a perfectly straight line, and therefore you don't have a perfect triangle. So we will be using techniques of calculus called integrals or integration to find the exact area that represents the consumer surplus. Let's talk about the deliverables, what you're going to do in the project. You're going to explore the different questions we've been talking about here in this video in much more depth, and then answer several key questions about things like optimizing profit, maximizing profit, elasticity of demand, consumer and producer surplus, and so forth. Your analysis will also include what we call what-if analyses, which are very important in the business world. Each individual person is going to write up their analysis in a written report and then take a project quiz with a new set of data toward the end of the quarter. So that's an overview of the project. Through the course of several weeks and several updates, what we call project updates, you will take your individual set of data, apply the ideas and the content from this course, and at the end, you'll have a really sharp analysis of how to market your particular product to maximize profits. See you online.